close these. Otherwise, it records all of these boxes. You guys can't see them, but I can. Okay, today is all about the last thing on quadratics. You're just going to wow me with everything you know. Okay, so the first thing, we have two formats. This happens to be Vertex format. So Vertex format is always y, and I'll put ax minus h squared plus k, where the vertex is h comma k. And a is the same as the a on the other one when it's in vertex form. But when it's in standard, we have two formats. We've got ax squared plus bx plus c. This a tells us something. The a is the same in both. I mean, it basically stands for the same thing. But it gives us some information. Here's what you're going to tell me today. Which way does it open? Is it a minimum or a maximum? What is the vertex? Once you get the vertex, you should immediately be telling me the axis of symmetry. You should be telling me the minimum or maximum, the equation of the line that goes with that minimum or maximum, which I'm about to explain all this. And since it's a video, you guys know you can stop and start and figure out, what you need to do. All right, so axis of symmetry, minimum or maximum. And then next thing I want to know is the y-intercept. And then I want 2 more points. And then you're going to graph and shade. Now, if some of you want to find the x-intercepts and wow me even more, like you want to use the quadratic formula or you want a Squeb-Futzer, please, this is where you get to show off. No, it's not SQU. I'm so used to putting U. It's Squeb-Futzer, solving quadratic equations by finding the square root. Okay, I'm about to do all of this. Okay, so here we go. First thing, and I want you guys to help me. I want to know, how do I know if it opens upwards or downwards? What in this equation tells me, does it open upwards or downwards? Somebody chime in, and I hope I have several of you fighting. How do we know if it opens upwards or downwards? Here's our problem here.
If it's negative, it opens down.
Thank you. I have a couple of you just logged in. You look at the leading coefficient on this one, the number in front of the parenthesis. Well, there's a negative there. It's really a skinny -1. So if a is greater than 0, if it's a positive number, then it's going to open upwards. If a is less than 0, it's negative. Okay, you're right. The leading coefficient tells us. So this one's going to open down. Now, I have to draw these because I'm not real good at math. Because I don't know when it's a minimum or maximum, I have to look. The vertex is our minimum or our maximum always. But if it's one going downhill, see how the vertex is going to be at the very tippy top of that roller coaster? It's at a maximum. That's the highest so this is going to be a maximum today. Okay, the maximum. Okay, let's go for vertex. This is in vertex form. All we have to do is the opposite of what's in here. So -4, 2. So I'm going to graph -4, 2. There we go. I'll label it vertex. Okay, now immediately what you should be doing is saying, hey, I know that if the vertical line that goes through the vertex is our axis of symmetry. Okay, axis of symmetry. How do you label this line? Well, remember the Hoy-Bucks. If it's a vertical line, the slope is undefined, but the equation is going to be x equals some number. That's why I make this up. So x equals, it looks like -4. That's the equation of this line. Then I might also do, since we know that's the maximum at 2, I might do the horizontal line through the vertex. That tells us the highest or the lowest this graph is going to be. But since I know it's going downhill, I know that's the highest. That graph will never exist up above that line. Now I want to also give me the equation of that line. Well, it's still Hoy-Bucks. It's going to be y equals some number. It's going to be y equals this. This is x. This is y. The thing that's neat, the x is always your axis of symmetry in the vertex. The y is always your minimum or maximum, depending on if you have a minimum or a maximum, which you decide from up here. So it'll be, this line here is going to be considered the maximum, and it's going to be y equals 2. Okay, and that's what I say. Once you find the vertex, automatically go to axis of symmetry. X equals. And I just know I see the X right in axis of symmetry, so I remember it's X, and it's the X part of the vertex. Now I'm going to go for min or max. We know it's a maximum, so I cross off min. And it's going to be y equals, well, y is going to equal the y part of the vertex. Okay, now I want someone to wow me with their infinite wisdom and tell me, how do I find a y-intercept on any graph in the whole wide world? I don't care what the graph looks like, what the equation looks like. How do you find a y-intercept? Anyone know? Think about it.
Would it be a line passing the y line?
Okay. So tell me, what do all these points have in common if you were to label a couple of these points?
Like,
label.
What do you mean?
Okay, well, if I were to circle a point right here, how would you label that point right there?
It would be 0, -4.
Okay, and label this point for me right underneath it.
Oh, it would all, like, the x would all be 0.
Thank you. That's all I want you to remember. If you ever want a y-intercept on any graph, any equation, you substitute in. Today, subbing for x is 0. Yay, round of applause for us. So we're going to sub in x equals 0. Round of applause for x equals 0. We're going to plug it into this equation. So I've got to come down here and do a little bit of work down here. I'm going to zoom out a little bit. I didn't leave myself enough room to do the work here. Sorry. Y-intercept, the original problem says y, and I'm just writing equals because all I need this greater than for is where to shade and what type of line to graph. -1 times x plus 4 squared, that's the original equation. Subbing today for x is anytime you are finding a y-intercept, x is 0, guys. X equals 0 is coming in right here. So we got y is equal to -1. Oops, I forgot to write it. There's nothing there. You're right. I'm going to zoom in so you can see me do this work. There we go. 0 plus 4 is 4. I rewrite everything, and you guys think it's silly that I'm wasting paper. I would rather you plant a tree, waste the paper, and make yourself really good at going through the steps and the motions of this. It'll get up into muscle memory. 4 squared is 16. -16 plus 2, I get -14. It's not necessarily something I could graph because the graph isn't quite big enough, but I want to know this. The y-intercept is our starting point on any graph. Okay, if we're talking about real world situation, like when I was talking about throwing the football a little bit ago, okay, you go to throw a football. Okay, it doesn't start from ground 0, and this would be like at 1 second, 2 seconds, 3 seconds, 4 seconds. But the y-intercept tells us how high was the ball when we started. Or if we're starting a savings plan, how much money did we have in the bank when we started? What was our maximum amount in the bank? And when did we hit 0? When did we go negative? Actually, that would be one that actually could go under there if you had a bank account. Okay, so the y is our starting point. It's an important point we need to know. The vertex is important. It tells us where it changes direction. Okay, the x-intercepts are important, which is the quadratic formula. Okay, y-intercept we got. I'm going to go and graph 0, -4. Oh my goodness, guess what? I'm going to call that point P. Okay, and because I want you to remember that 1, 2, 3, 4. This is 4 away from the axis of symmetry. 1, 2, 3, 4. We have its alter ego mirror image called P prime on the other side. Give it a second. I know that the skylight's messing me up. Okay, I told you to give me 2 more points. Well, I told you go to the axis of symmetry and go to the right and pick that number and the next number. So I'm going to put in x equals -3, and then I'm going to put in x equals -2. Here's why I want you to pick those numbers. Because the further you get away from the axis of symmetry, the farther down you have to go, and it won't fit on your graph. So I'm going to go ahead and plug in x equals 3 into the original problem and see what it spits out. So -3 is coming right here. -1, -3 plus 4. I want to show you something that will happen every single time you do that. If you go 1 away from the axis of symmetry and put in that value for x, look what I get in this parenthesis. I get a 1 because I'm 1 unit away from the axis of symmetry. This is why I choose these numbers, because I work really well with the number 1. 1 squared is 1. times -1, I get -1 plus 2. So I got out of 1. Input a -3, I got out of 1. Mirror image. So if I want to call that point Q, this is Q prime. Now I'm going to stick in a -2. And I'm telling you, I'm 2 away from the axis of symmetry. I'm thinking I'm going to end up with the 2 in here. But let's see what happens. -1 instead of x. Today, summing for x is -2. Round of applause for -2. -1. Oh, -2 plus 4 is 2. Ooh, my prediction happened. When we're 1 unit away from the axis of symmetry, I got a 1 in here. When we're 2 units away, I got a 2. That's pretty weird, Miss Sweat. No, it's not. It makes total sense to me because we're adding or anyway, shut up, Sweat. -4 plus 2, I get out a -2. So I put in a -2, got out a -2. I'll call that QPR. It doesn't matter what you call it. Just know that it's got a mirror image on the other side. What went wrong? Is my y-intercept correct? Oh, did anyone correct me on the y-intercept? 4 squared is 16. Oh, it's 14. Guys, I graphed 4. Sorry. This should be way down here at 14. 1, 2, 3, 4. I did wrong on the y-intercept. This point's not there, and neither is that. Nice example, Sweat. Way to screw things up. You're welcome. Hope I didn't confuse you. The y-intercept is -14. I wrote -4 up here. And then I graphed -4. I can't graph the -14. I'm so sorry. But I'm going with it because I think this is a great video. Shows that even I can make mistakes. Okay, now I need to know what I need to shade. That's where I take my sign. Greater than or equal to. I'd look and see if it matches my left hand. It does not, so I need above. This is greater than because it's not making the L for less than. So this is greater than, which means I'm the greatest. I'm on top. Okay, above, whatever you want to call it. Greater than. You're the greatest. You are on top of the world. Underline means it's a solid line. And I apologize again for doing, I knew it was wrong though, because I was trying to line up my parabola and I was way out here. It didn't line up. So I knew something was wrong. Okay, so it's easy to lose things. Anyway, there we go. It's a solid line. Now I have to decide where to shade. Greater than, on top of this roller coaster. I'm going to go ahead and shade in orange. Where's my orange? Here it is. Here we go. That means on top I would be shading everything here. Let me get my hand out the way. I'm going to zoom out. You're going to wow me like that. You're going to show me every